आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In this podcast, we are happy to present Dr. Sidharth Kumar Prasad, a faculty from the Department of Physical Sciences in Bose Institute. His area of research is related to high-energy nuclear physics. But before going into more details about his research work, let us hear from his own voice about his academic journey.
My name is Dr. Sidharth Kumar Prasad. I am a faculty here at Bose Institute, Kolkata in the Department of Physical Sciences, and I mostly work in the field of experimental high-energy nuclear physics. Before coming to Bose Institute, I did my PhD at Variable Energy Cyclotron Center, Kolkata, and during my PhD, I worked mostly on two things. One thing was the testing, installation and commissioning of a very important indigenously detector, that is photon multiplicity detector, in the Large Ion Collider experiment at CERN, Geneva. And second thing, I was involved on the analysis of physics problems. In the detector part, I was mostly involved in the testing, quality assurance, and installation, commissioning, and maintenance of the detector. So India built in collaboration with many institutes, around 6 that time, an fully indigenously detector for the ALICE experiment at CERN, and it was installed in 2008. That time I was there at CERN, and after that it continued taking data till 2018, 10 years. And during that period also I continued looking after this detector, operation and maintenance. And parallelly I also studied the data collected from this detector. During my PhD, we published one paper on this detector, and interestingly, one of my students also continued, and very recently we published another paper, and main outcomes of that paper is also highlighted by the prestigious CERN Courier, which is published at CERN on bi-monthly or monthly basis.
ALICE experiment is not a common word to common people. Dr. Prasad shares some interesting information regarding this.
I will now discuss more about my current work. So mostly right now I am involved still in the ALICE experiment, which is an international collaboration. And the basic aim of this experiment is to understand system known as quark-gluon plasma, which is expected to be there just after the Big Bang. This is the state of primordial universe, you can say. So we are mostly focusing on studying the properties of that system, which is mostly governed by the theory of strong interaction. That is also one of the goals, to understand the theory of strong interaction. And since this system is created after the Big Bang, so if we want to study this system again, then one foremost thing would be to create such systems in the laboratory and perform the studies. And fortunately, with the current technological advancement, we can create such systems in the laboratory by colliding two heavy ions, basically the nuclei of atoms, lead atoms, at very high speed, such that the energy which is given to those nuclei is of the order of TeV range. And in that energy, if you collide, then such systems are created. But those systems are created for a very short time and in a very tiny phase space. And just after the creation, the system disappears, and resulting into lot of particles around the collision point. So as an experimentalist, our aim is to detect most of the particles which are produced, because those particles are the only carrier of information from where they are produced about that system. So we detect all those particles, and then we study their properties, and based on their properties, we try to correlate their properties to the properties of the system from where they are produced. So that deals with lot of challenges in terms of technology in building the detector for detecting the particles, and later on analyzing the data which are collected for physics interpretation.
Dr. Sidharth Kumar Prasad speaks about his collaborators.
This is a collaboration among ourselves in India. So there are 16 institutes together which are collaborating, which is known as ALICE India Collaboration. And I am also being the deputy spokesperson of that collaboration right now. And then we collaborate to the CERN, ALICE, a Large Ion Collider experiment at CERN. In India, we are about 150 collaborators, around 50 faculties, less than 50 faculties, and more than 100 students. And worldwide, we are around 2,000 collaborators, including more than 50 countries in this collaboration.
Dr. Sidharth Kumar Prasad points out that their research work has a great contribution to that society.
So, first of all, we are dealing with trying to unfold some of the unknown concept of physics, which we do not understand fully. And if we, through this experiment, if we little bit understand some experimental facts comes to understand those things, so in long run, that will be itself a large or very great contribution to the welfare of mankind. In addition to that, there are a lot of intermediate applications while doing these kind of big experiments. For example, when we perform these experiments, everything is done underground. All the equipments, everything is put 50 to 100 meter underground, and we control everything from a control room. So what we do from the control room, we control and monitor everything, because we cannot go inside because this is a high radiation area during the run period. And those kind of concepts are, to my opinion, is the kind of state of art and can be used elsewhere also. For example, one can think of putting these concepts in big hospitals. Like you put a central room, from there you monitor all the patients together and put some experts there for quick monitoring and assessment. This is one of the area one can use, but in elsewhere also in big corporate house and other places, this is a very naive and very elegant way of monitoring centrally in a remote way. So after a lot of efforts for 1 decade probably, we built all these instruments, and that was also built in different part of the world. They were brought together at CERN, and then they were installed inside the cavern, which is underground. After that, for running all those instruments, all the softwares and frameworks were developed, and India also participated in that earlier. Later on, during the run period, it's 365 days, 24 hours, continuously running. Though there is a mechanism of taking shifts in the control room, where all countries has to participate and everybody has to contribute. So we go there time to time, our students go there, they participate in the experiment, they participate in the control room, and also physics discussion continues on the outcome of all those data coming from the big experiments.
Dr. Prasad shares some of his experiences during pandemic time, how they have continued their research work.
During the COVID, what happened, because physical in-person going CERN was difficult. So that time CERN decided to remotely set up few replica of those control rooms, and Bose Institute happened to be one of the institute who developed this control room, and we have one such control room here also. From there we can control all the experiments going on at CERN.
Dr. Prasad speaks about his global collaborators and shares his views on India's role in global context.
Most of the developed and developing countries, more than 50 countries, so you can name any, India, China, Japan, Russia, US, Germany, all countries are participating. Yes, India is playing key roles in several aspects. For example, I am also one of the convener of one of the physics working group, and the goal is to define all the physics in that working group. So in that sense, and there are many more roles India is playing there in this.
Dr. Sidharth Kumar Prasad also speaks on the way forward.
So we are still not been able to finalize the properties of QGP, after which we are for so many years. So right now these experiments are still in the upgrade stage on experimental basis, because we are unable to cope with the theoretical understanding. So we have to do more experiments, and at least for next 10-15 years there are programs defined with certain goals.
Dr. Prasad also speaks about those days when they have done their practical research work in underground.
As I mentioned, this experiment is built underground, about 50 to 100 meter under the surface. So during the installation, we have to go inside. It is a kind of cavern or tunnel, you can say, with all our equipments, and we have to stay there. We have to install there all the equipments, all the proper arrangement for the evacuation, safety things are there in place, and also the air control and all those things, because underground you have to struggle with lot of other things. Those things are there, and before going down you have to take a proper training and safety norms you have to follow. With all those, you with your helmet and shoes, safety shoes, you go inside, do your job, install your part, test it, and then you come out from there, and then from the control room later on you can look at that. And this underground tunnel is around 27 kilometer in circumference. So it is under all the Switzerland and France area. It is under the mountain, it is under the lake, and this 27 kilometer circumference, there are 4 such experimental facilities. So one is ALICE, where Bose Institute is participating. Then another one is CMS, where other Indian institutes are also participating. And then there is ATLAS and LSCB. There are 4 such experimental facilities.
We are thankful to Dr. Sidharth Kumar Prasad for providing us with his valuable time.